Welcome. Welcome, everyone, to Wharton Moneyball, the show where sports, statistics, and business all intersect, three of my favorite topics. This is Eric Bradlow, professor of marketing and statistics and data science here at the Wharton School. Some combination of myself, my co-host and friend today, Adi Wyner, are here every week. Sometimes it's us two, Cade Massey, Shane Jensen, but this week it's Eric and Adi here on the Wharton Podcast Network. I think for those of you that have been on our show or been with our show for the last 11 plus years know, whenever it's me and Adi, I take this opportunity to, in some sense, interview Adi. So today there will not be a guest. I will interview Adi for, if you'd like, an hour or so during our podcast. The first part of the show will be our standard What Caught Your Eye in Sports segment. Then the second half, you're all in for a real treat. As I think many of you know, Adi, besides being the co-faculty director of Wasabi, this Wharton Sports Analytics and Business Initiative, which is part of the bigger umbrella brand that I run, the Wharton AI and Analytics Initiative, also it runs our faculty research with our undergraduates, and he's going to talk to us about the research they're doing in sports analytics. So the first half will be What Caught Your Eye in Sports. The second part will be what Adi is doing with our brilliant Penn undergraduates on sports analytics and research. So Adi, how are you doing today?
I'm doing really well. Excited to have a good conversation with you, Eric. I know that there's going to be a tremendous temptation for us to spend the entire time talking about the Yankees, but we won't do that, at least not exclusively. And I look forward to talking to you about the work that our students are doing, which are not only includes undergrads, but also graduate students, our PhD students, as well as some students who are masters in data science. And we even have a PhD or two from other departments.
Well, I know at one point, I think Ryan Brill was AMCS, or some students were AMCS.
Ryan was AMCS. He was in applied math, and now he's with the Utah Jazz. He actually came and visited. He talked about one of his. He talked about some of the difficult problems in general.
Well, we'll get to that. We'll get to that in the second half of our show. So what I wanted to start with today was the NBA. So something very interesting is happening in the NBA. So, and it's maybe the most extraordinary start to a season that I've ever seen. I would just like your take on it from a statistical perspective. A very specific question. So the defending champions, the Oklahoma City Thunder, they won the title last year, as you may remember.
I do remember.
They are 17-1 to start the season. Right now, the forecast number of wins for them is 68. Now, you might say, well, that's a huge number. Maybe, except they're 17-1. If you just projected that out, I'm not saying a linear projection, multiply it by 3, they would be 51-3 in their next 54 games. Now, we all don't predict that. But for them to beat that prediction of 68, they just need to go better than 51-13. So let's be clear. They're on a 51-3 pace right now, and 51-13 gets them to 68 wins. So why don't we take it piece by piece? Would you go over 68, knowing, by the way, you may remember, the highest number of all time is 73. That was the Golden State Warriors of, I think, 2017, who lost in the finals, you remember, to LeBron.
Yep.
They were 73-9. Of course, the Michael Jordan Bulls, I forget which of the years, was 72-10. I think that might be, maybe there's one other at 70, but the next gap, I know there's a 69. So let's just start with that. And I've got two other things to say about the Thunder. Right now, how would you help our listeners here on Wharton Moneyball, on the Wharton Podcast Network, think about how likely is it above 68-14, or possibly even the record of all time?
Well, there's two broad ways to approach this. One is the way you did already, which is just look at what is the best seasons ever and essentially ignore any individual information we have about OKC. They've won 17 and lost 1. Okay, we'll just put that in the bank, and then we'll use that, and we'll ignore that, and we'll just say, how likely is it that they're going to be one of these top 5 teams ever? And I guess 68 wins would put them, what, 7th, 8th best team ever?
Yeah, probably exactly in that range.
And considering that, and that essentially asks that question in that way. And in which case, we are really not really thinking too much about the individual team. We're just saying they won 17-1. All the data suggests they're a potentially all-time great team. Where would you put them? 68 seems reasonable. I don't think that's where it came from. My guess is the estimate came from some sort of Bayesian updating, which is a tool that we've done a lot of in this program. You essentially shrink or regress to the mean to estimate what you might call their true win rate. So we don't believe they're really a 17 out of 18 team, which is like a 93% win rate. We think they're something lower than that. And the question is, by how much do we regress down to the mean? And so we're essentially predicting that they go what 50, what'd you say, 51 and
51
13.
and 13,
So
which is
that's their like 75%,
80%,
little
80%.
80%. So we're saying the rest of the way. So they're 93% win up until now. The best estimate of what their true talent is 80%, and that leads to 68. That's probably what they did.
Right. So would you reasonably treat this as, the classic beta binomial situation? And what I mean by that is we have a prior for OKC, we have a prior for every team. Now, obviously, this part I can do this, it's not even math, it's intuition. If they're 17 and 1, which is 93%, okay? And the prediction is that they're going to go 80% the rest of the way.
Mm-hmm.
The prior must be below 80%, because if the prior were above 80% and the likelihood were above 80%, which we know it's 93%, the posterior would have to be a convex combination of those two, which means that the prior for the Oklahoma City Thunder might have been, let's even say it was 75%, which is not unreasonable. Maybe they were projected to be a 60-61 win team, which is 75%. They're 17 and 1. We're now up to a prediction, as you pointed out, of about 80%, and that's our prediction for the rest. That sounds about right, doesn't it?
Yeah, it does, but I don't think so. There's two ways to do this Bayesian, this shrinkage. Do you shrink to a prior that's specific to the team, or do you shrink to the league overall prior? And the difference is a prior shrunk to the specific team has much smaller variance, right? So if we're talking about OKC, given what we know about everything, what they did up until this season, we probably have a 75% centroid, maybe, or posterior or prior mean, and probably a pretty small standard deviation. And therefore, we shrink pretty heavily, despite the fact they got 17 and 1. We still shrink pretty heavily back to the prior, just put it up a little higher. The other way that you could do it is just pretend this is the only thing you know about this team is that it went 17 and 1. That's it. You know nothing about the previous years. And then you shrink to 50%, but
Right.
your prior mean would be huge, much, much bigger. And so the current data would end up getting much more weight. So you have two choices. You either shrink heavily to a very high mean, or you
I
shrink
have
much
a vote.
less.
I'm shrinking towards the OKC one, but I do agree with you. Either one of those conceptually, depending on how much sample size you put in the prior, could lead to the 80% number in this case.
Either way, it's interesting on how to do this.
It is interesting.
So I probably would have had a multivariate. I would have lumped other teams into that good team prior instead of
Not
just a
just
general prior,
OKC. Like,
and try to borrow something else. But that's not. I don't want to try to do this myself. We're trying to predict them whether or not. And so essentially, I guess the prior one would get to an 80% going out. I think that 68. I think they're going to go over. That's my
I
forecast.
think so too.
I
So
think that
here's something else about them that's interesting. Right now, their projection is to win the league by 10 wins. That means they'll have 10 more wins than any other team. Now, that would be a historic
mark. Now, can I ask just one question, a particular question? I don't know. Has their schedule been average, difficult, easy so far? What do we know?
It's a good question. Somebody knows.
Yeah.
This somebody doesn't know.
Yeah.
But
Yeah.
the answer is, I don't know. That's a fair question. I mean, we're starting to get to enough that you and I would agree it's hard to believe it's much below 500, if it's at all below the 500 of the teams they played, right? Because, eventually it's going to average out to a certain schedule.
Well, the problem is in the NBA, there aren't that many great teams.
No,
right?
that's the problem, right? So your
And
point
have they
is
played them?
there's no information. Like, I hate to make this up, but they could be equivalently like 5 and 1. Like, of course they
Right.
beat those 12 teams. And
Yes.
then there's like 6 games. All right, you went 5 and 1 in tough games. All right, well, all right. That's
Now they played How many games coming ahead do they have against really good teams
I
away?
haven't looked at that. And by the way,
That's a
you
tricky thing
pointed
about
out
that.
another way to do the prediction, which is we actually build a simulator game by game. We play that out, and then it takes into account who they're playing, their relative
Right. No,
strengths.
that's the way to do it. The difficulty in doing that simulation is that you have to put in some sort of talent metrics for everyone. And we've been talking about this on our show with Cade on how to simulate going forward. Do you either put the uncertainty in the parameter estimates before you start the sim, or do you treat the parameters as fixed and then you just re-estimate them as you go through the sim? If you are fully Bayesian, that those produce the same and are correct about the priors, that produce the same answers. If you are not fully Bayesian, if you just and you just want to add uncertainties to some, say, MLE, then you'll get very different results.
Agree with that. Let me point out something though that people might do though for practical reasons, and then we'll move on. This is more of a technical comment here, but the first one you mentioned, where you fix the parameters but then add the simulation error later as you go through because you rerun it, kind of. That one, of course, will take potentially less computation because you've batch processed the data and you've generated a posterior, and now you're just adding one observation at a time, which there are other ways. All I'm pointing out is there could be computational advantage to do sequential simulation one step
But it
forward.
also depends on what your algorithm is. So if you have just some algorithm that estimates team strengths,
Oh, then that's
then you
fine. That could
then
be done
fundamentally
fast, and then you have there's no advantage. Just one other thing about the Thunder before we move off the NBA. We talked about this last season. In some metrics, they had the greatest season in history last season. Forget number of wins. Their point differential broke the record. I think it was somewhere around 11.5. So right now, Adi, they're at 16.9.
ridiculous.
So at some point, we're going to have, like, let's say they win the title again this year. Let's say they win 70 plus games. Let's say they have a point differential of 13 plus. We're going to have to start talking about this OKC team as being, it's not a dynasty yet. Two doesn't necessarily get you to some definition. But we're going to have to start talking about them as one of the greater teams. I don't know, the top 5% of teams all time. I mean, if this happens.
Is it? And but the trick is to me, yes, of course we would. But my question is a basketball one. What is the anomaly? Is the anomaly because they don't have? Is it the anomaly that Shea is really a great player, like is he LeBron level, all time Michael Jordan level, and we've just underestimated him, or is it a team that's extraordinarily well constructed that has no weaknesses that have found that defense is extremely important, and while it's not flashy, it's
Right.
the way you make big
That's
point
a
differentials in
great
big games.
question. If you're asking me as a basketball fan, what I would tell you is they're an extraordinarily well-constructed team, that Shea Gilgeous-Alexander is the best player or top 2 or 3 in the NBA right now, but he's not Michael Jordan level talent
At his
or any.
prime, sure, or even Seth Curry at his prime, or
Right, probably not, but
on.
he might be in that next tier down. And then they've got a bunch of very, very good other players. And so you take a great player and a bunch of very, very good other players, and you might get there. And they seem extremely well balanced. So either way, I don't want to spend all of our time talking about the NBA. I was just
Neither
noticing
do
their
I.
record's incredible. I'm glad we talked about some different ways to do prediction, whether it's through shrinking to their prior, shrinking to the league prior, a simulation based prior, but also this point differential is just incredible right now. And at some point, we have to say, I understand it's only 18 games. Okay, so next week, Adi, if we're sitting here and it's 23 games and they've got a 16, 17 point differential, eventually we're going to start to have to say, we'd be surprised if they didn't break the overall record.
Yeah, I mean, not to say I don't have the number exactly offhand, but I believe the RMSE on predicting wins given your point differential is 3, meaning that I can predict your total wins just using your point differential to win at about plus or minus 3 wins.
But how well do you think that'll work in the tails? How do you
Ah,
think?
so the data that I fit it to, right? So which is every season up until this year, doesn't seem to have a nonlinearity at the tails, or it's not drifting.
Well,
Um,
there has to be some because there is an upper bound. You can only win so many
right,
games. But
right.
but
I'm
and
just predicting. It just seems to. I mean, it's not. It's. I'm not predicting. So I just predict wins. I mean, you could predict winning percentage and then do a logistic, and then predict a logistic. Those are two. Now we're getting really in the weeds here for our show. I don't want to. I
all
don't
right.
want to get into this. But just to say that if they can hold 16, they are going to break that record easy.
I think it's easily. Yeah. All right. So let's move on. Let's talk a little about the NFL. Now, of course, we could talk about the Eagles game and all that, but I don't want to talk about that for just a second. So I just downloaded the ESPN power rankings for the NFL. Okay. What team do you think is number one?
Rams.
That is incorrect, sir.
Is it
They are
still the Eagles?
nope.
Colts?
So far you said the Rams, they're second. You said the Eagles, they are sixth. The Colts are five.
Who am I missing here? The Patriots? I mean,
They're not even, they're like 15 or 16.
yeah, I mean,
It's the Chiefs.
the Chiefs still got him up there.
This is the part this you have to explain. So
What,
I know
five,
this is
7-5?
current. Let me just be clear. I know this is current because it has their record at 6-5. That's their actual record now. It has them at 7.1 points above average. It has the Rams at 6. So that means they're a 1-point favorite against the Rams. The Packers are third, but let's say they played the Eagles. Right now, it has them as a 2.7. Let's say they played the Patriots. It has them as a 6.6 point favorite on a neutral field.
Well, what are the underlying stats? I heard one stat that I'll share with you.
Okay.
That I was trying to make some heads or tails of this. I saw this on Sports Analytics Twitter. Um, Someone pointed out that the KC, the Chiefs, have the highest number of yards per drive. So basically, how many yards are they averaging per drive? And they're just about 40. And they showed that the teams at that level historically go 12-4, 13-3.
Just so you know, by the way, I think you remember last year that Chiefs were something like 11-0 in one-score games. Just so you know, they're at least well, I guess it just changed. Up until this last week where they beat the Colts, they were 0-5. They're now 1-5 in one-score games.
One-score games. So this particular stat suggests that this underlying metric, which doesn't take into account special teams and
Right.
things like that, and starting positions. So, for example, you'll expect more yards on your drive if you start deep in your own territory. You have more room to go. Um, and I don't know whether that number means anything. It's like a peripheral that correlates with team quality, but they were number one in it, and usually historically teams with that level of success in terms of yardage have been great teams. And so they're essentially, that one number suggests that the underlying metric suggests that the KC is much better than they appear based on their record. They've lost a bunch of one-run games. They've had some bad special team turnovers. They've had some what you might just jump into and lump into one big pile called bad luck. And bad luck is not supposed to continue. You should expect neutral luck. So if their underlying strength parameters are excellent, you might, and given their historical performance and of course who their quarterback is, and the fact that everybody seems to be beating up on everybody else, maybe they do land that high. But I have to tell you, I'm surprised.
I am surprised too. And by the way, the only other team that's 6-5 in the top 12 teams, not surprisingly, and this might be the role of priors. Well, who would you guess? Who's the other 6-5 team that the priors are going to bring way up to?
Oh,
Who?
Bills?
That's a great question. It's not the Bills. The Bills are 7-4, by the way.
Okay.
It's the Ravens.
The Ravens, right? The Ravens are another one. They also have prior history, and I wonder what this is. ESPN. The ESPN might have a lot of weight on.
Well, that's why I was asking you, because I think most people would find it shocking that the Chiefs are the top. I think a lot of people might find it surprising that essentially the Eagles and Ravens are equal. The Ravens are better than the 8-3 Seahawks, the 7-4 Niners, the 7-4 Bills. The 9-2 Broncos are like 12th. The Patriots at 10-2 are
Yeah,
like 15th.
yeah.
So either way, I thought it was just interesting to talk about
They've
the.
had to jet twice, probably.
By the way, let me just say for all of our sports. So as everyone knows, we record Wharton Moneyball on Tuesday. This is Tuesday, 2 days before Thanksgiving. There's an amazing schedule on Thanksgiving, Adi. I don't know how much you're going to get to watch. The first game is Lions and Packers. I mean,
That's a great game.
that's a
Did
big
the
game.
Lions traditionally play on Thanksgiving? I guess there's more games than one now. They used
The
to just be
Lions always do, but they're 7-4 and the Packers are 7-3-1. The second game, all of a sudden now became fascinating, Adi. Chiefs at Cowboys.
wow, with the Cowboys beating the Eagles last
So
week.
6-5.
Horrendous.
I know, but 6-5 Chiefs against 5-1 Cowboys. A week ago was like they're both going to lose. It's going to be two losing teams. Now, all of a sudden, these teams are in it. And the night game is an interesting one because Joe Burrow's coming back. It's Bengals at Ravens. So all of a sudden, we actually have three sort of interesting games on Thanksgiving Day. One thing I'm going to take advantage of because it's you and me here. So I want to talk to you about the Hall of Fame, the Baseball Hall
Of course. How could we not, Eric? It's our dream.
We're going to. But, okay. So I want to remind everybody there's two separate committees that are going to be voting this year. Okay. One is what's called the Contemporary Era Committee, which used to be called, I don't know if it was the Old Timers Committee or anything, but there's two
Veterans Committee, wasn't it just the
Veterans
Veterans?
Committee. No, but they've split it up, remember, Adi. There's 1980 onwards, which is the Contemporary Era candidates, and then there's pre-1980. So here are the 7 candidates in the Contemporary Era Committee, okay? Roger Clemens. So we agree and by the way, you need 75%, I think, of like 16 voters. So he's not going to get it. Okay. Carlos Delgado.
Carlos Delgado. I don't see him getting it. I wouldn't imagine he deserves it either. How about you? What do you think?
473 home runs.
Yeah.
3-time Silver Slugger. I don't know, right on the border. Jeff Kent.
On the border also, this is I mean, Kent, what was he? His was a middle infield position, wasn't he?
Yep,
Kent?
second baseman. I think
And
he has the most home. Yeah, it says here in my notes, he has the most home runs ever by any second baseman.
I think he has a better shot than Delgado.
Don Mattingly.
By the numbers, his career was too short. I can't sanction it. I mean, he definitely was the best hitter in baseball for about 2 to 3 years. And super competitive, hitting, 340s, winning batting title, 30s. One year, I think 145 RBIs, a statistic we like.
Remember that year.
We like to disparage, but is impressive. Great fielding first baseman, but just didn't have the longevity. I mean, he just you can't have only if you're going to be in only on peak, you have to have Griffey level peak, Koufax level peak. You can't
Judge level peak.
Judge level peak, Trout level peak. Look at Trout. I mean,
yeah, Trout
going to go into the Hall of Fame because of first 10 years of his career.
Well, that's a long peak. All right, how about Dale Murphy?
Also, first baseman. I don't see it happen.
All right, Gary Sheffield.
Chef was quite a hitter. I think his career statistics might be a little higher. I don't have them in front of me, but
509 home runs.
Yeah, and there's a majesty at the 500 homers, right?
1,676 RBIs.
I think he's got a good shot.
Okay. Fernando Valenzuela.
No.
Okay, just no. Okay. Well, those are the 7 contemporary. So you could see in your mind, you wouldn't be shocked if Jeff Kent got in.
No,
you wouldn't be shocked if Gary Sheffield got in.
No.
Okay.
I'm to listen to our listeners. I'm not staring at their numbers, and I'm just recalling what I imagine about these players. And I do think Chef's he had 500 homers.
509.
That's a mark that almost always gets you into the Hall of Fame. Kent's leading home runs at a second base position is really impressive.
Don't remember if there were PhD, performance-enhancing drugs, rumors about Sheffield. I think there were, which may be well keeping him.
Maybe why he's where he is.
Because you would think someone with 500 home runs and almost 1,700 RBIs
are going to shoe in, right?
Is in. I mean, that's in. It might be third tier, but you're in. Let's talk about the current ballot.
Interesting.
Now,
Well,
you just
I
say
don't
I
think
did.
there's anyone coming in on the ballot as first timer.
Yeah, so
It was a lot.
they're not in
And
my
that
list.
frees
I
up
looked at them and I just
the vote.
pruned them. There's nobody.
Yeah,
Nobody.
yeah.
Trust me, nobody.
hmm It's a great
So
year for people hanging on. So
yeah, so
Beltran should make it easy.
let's talk about a couple hangers on, and let's see if you think. So Carlos Beltran,
Yeah, this is his year. He was close last year
he's getting
with
in.
nobody. He's getting it. Yeah, this is year.
Andrew Jones in his 9th year.
It's either this year or next year he's getting in. So I would go for this year because I mean, what's the early reports? Do we have the early reports yet? I know we
I
like to
haven't
talk.
even looked. I know you like to look at that. I have
I
not
do
looked.
like to look at them. I like to look at. I like to look at the Hall of Fame
And that's
tracker.
probably it, right? Because of how far the other people, like the next person on the list is Chase Utley.
Chase Utley, I believe, will make it eventually,
but he's in
but
his
I don't.
3rd year at 39.8%. So he's not jumping to 75.
He's not getting anywhere close quite yet. Um,
And then, of
there
course,
aren't very many ballots out yet right now. So right now there looks like almost nothing out. So
okay. And then there's people, I mean, some other reasonable name, look, other names that aren't getting in because of possibly performance enhancing drugs. Alex Rodriguez, Manny Ramirez, obviously they would be in based on their numbers. Andy Pettit's in his 8th year, won't make it. Here's a guy, I've never quite understood. If you talk about peak performance over, what about King Felix?
he was great for a short period of time.
Well,
I mean,
last
extraordinary.
question, is DeGrom in the Hall of Fame?
Yes, DeGrom's. I think DeGrom. I think. Well, let me see.
Is DeGrom better than King Felix?
You know what? This is up my alley because I've done this research. So I'm going to give you. I can. So DeGrom hasn't retired yet. So I'm gonna pull him up. This is as many of you know, I worked with Ryan Brill and we created our grid war metric, which ranks every starting pitcher based on their quality. So I'm going to take a look to see where DeGrom falls. So the way our metric works is it takes the geometric average of the rank in your peak and
Rank
your
based on what?
your career. So your rank in the grid war. So our it's a war metric. So I have a annual grid war metric and you have your career grid war metric. So that's how we calculate it. So so if you want to just look, our metric puts Greg Maddux at number
And
one.
can you just speak, by the way, can you just for 1 second, can you say to people the advantage of taking a geometric mean as opposed to an arithmetic mean here? Like just take this, why don't you just take the simple average?
Yeah, you could do that. The advantage of doing that is it doesn't, if you have, so the problem with that is that, let's say, take Sandy Koufax. Sandy Koufax is 1 in peak rank. He's number 1. And he is 48 in career. So if you just took the average, you're not giving enough quality, enough kick to that number 1. And so, in other words, you essentially, it's a decaying term.
And the
So if you
geometric mean puts more kick into peak performance.
so the geometric mean for right. So it basically says that if you're really, really kind of low, you're just low. You're not there. And so if you're 48 or 100, it's not that different because it's simply the square root metric. And it really values a high value, and it doesn't just destroy you with an outlier on one of them. So it's a little bit. I think it has slightly better properties. And by the way, it's extremely efficient. It's everybody's in until you get to a point where everybody's out. So
That's
it really
great.
divides.
You're
It's a
telling me
great
it has literally a perfect
No, it's not
separating.
perfect. No, it has perfect. It has one person, which we've talked about repeatedly, who's not in it.
Not Kevin Brown.
It's Kevin Brown. He's the only exception.
You're telling me, wait, you're telling me, I just want to be clear for our listeners here on Wharton Moneyball. If I rank order pitchers by your metric, there literally is a line I can cut where everybody except for Kevin Brown is in and everyone below that number is
not
out.
everyone. No, not everyone. There's a couple exceptions, but it goes from almost everybody above except for Kevin Brown, and almost everybody below is not. But there are a couple exceptions. So Phil Niekro is
That's fine.
And Catfish Hunter, they're not exactly at the border. Kurt Schilling is not. I have to exclude those guys who didn't get in because of reputation. But you go down and you get every single person all the way down the list, and skipping over Kevin Brown, you get Max Scherzer, CC Sabathia. These guys are in now. Scherzer's in, And then the one borderline case, this is my favorite one, the actual borderline, the guy who sits on the board who is nodding, is Dave Steve.
Well, I know you've talked about Dave Stieb so many times. Like, and you've come to the conclusion that Kevin Brown is more deserving than Dave Stieb.
He's more deserving, yes.
Okay.
Yeah.
So, is there a planet that we live on where this Veterans Committee, or whatever they call it now, current era committee, like Kevin Brown or Dave Stieb, gets in?
Absolutely. It really depends on how analytics focused they are, right? Because the case for Kevin Brown and for Dave Steve rests on having extraordinarily good peak performance and nice long careers. There's peak performances are for both of them are majorly undervalued, and they're undervalued because of win-loss records.
Hmm.
And
Well,
particularly with Kevin Brown, these years he pitched for the Padres. He was a 500, slightly better than 500 pitcher, but was the dominant pitcher
all
in
right. So
his.
let's make a prediction now. So Eric Bradlow and his three sons. I'm at Cooperstown, like I am. It's July, whatever, 24th or 25th next year.
Mhm.
You're telling me I'm going to see Carlos Beltran. You're telling me you think I'm going to see Andrew Jones,
Mhm.
potentially. You're
Yep,
saying, and I might see Jeff Kent, and I might see Gary Sheffield.
that's right. That's about it.
Okay.
Now, but I found King Felix, by the way. King Felix is number 42, ranked, and there's nobody ahead of him. There's a whole lot of people ahead of him who aren't in. So,
That we're
um,
not in, that are not in.
we're not in, and I don't think he's gonna. And if you just look purely based on the quality, I don't think you're seeing it.
I
Um,
see. I see.
but he had a lot. People sort of loved him, so you never
I got to
know.
admit, if you tell me I'm going to Cooperstown to see Beltran, Jones, Kent, and Sheffield, I'm thinking, I have tiers of Hall of Fame. The sum of those four is 12. I don't care what you tell me. Like, there's
Oh, of
no,
course, without a question.
no, I'm just saying that doesn't excite me that much because
No, it doesn't.
I
It
mean,
doesn't.
it's not that exciting. Well, Adi, we've talked about NBA, we've talked about some NFL and rankings, we've talked about some MLB. I'm glad to hear again about your metric with Ryan Brill. This has been the first half of Wharton Moneyball here on the Wharton Podcast Network. Stay with us after the break, and we're going to talk to Adi about him and his students and the research they're doing. So come join us after the break. Welcome back to the second half of our show here, Wharton Moneyball, the Wharton Podcast Network. This is Eric Bradlow, Professor of Marketing, Statistics, and Data Science. I'm here with my colleague, co-author, and friend, Adi Wyner, Professor of Statistics and Data Science. Some combination of the two of us, Cade Massey and Shane Jensen, are here every week on Wharton Moneyball. And as I mentioned at the beginning of the show, one of the advantages, although we love it when everyone's here, one of the advantages when it's just Adi and me is I basically get to interview them. And so I just talked to him about some statistical stuff having to do with the MLB, NFL, NBA in the first half of the show. Now I thought, let's pull back the curtain on what Adi has spent, I don't know, at least the last 10 plus years, maybe 15 plus years building, which I consider the greatest undergraduate, master's, MBA, PhD level research opportunity for people that want to apply statistics, machine learning, now AI, data science more broadly to sports research. So Adi, I have no guide to you except, why don't you start by telling us one of the projects that you're working on now or recently that excited you, and we'll get to as many as we can in the second half of the show.
So that's great opening. Just to give you the listeners a little bit of introductions, we have many students who are doing research in statistics, machine learning, computer science, mathematics, and their research is in some sort of sports application, which is a really exciting for them because they're close to the edge, right? And one of the way we introduce our in our seminar when the research is think about something that's caused you to think about a problem. What are you curious about? And then try to get the data. So we have lots and lots of projects going on. Most of these are some of them have already been published. Some of them have won prizes across different sports. So we have it. Surprisingly, we don't have any basketball, but we have rugby, a few in football. We have tennis. We have obviously we have baseball, and we have and
Let me ask
sort
a
of
question.
general.
Let me ask a question related to that. So one of the things in in our open source publishing that we have now, let's imagine there's one of our listeners on Wharton Moneyball that wanted to either replicate or extend some of the work that you've done with your students? Like, are these data sets public? And number two, if you publish the paper, do you also publish code and data with it? And like, which some journals require now, some don't. Like, how would one of our listeners, if they wanted to say, I want to see how my skills are, I want to replicate Wyner and Brill or somebody else, how would they do that?
Depends on the sport. So everything we've gotten from football is either public through event data, next generation stats, just public event data, or from the NFL Big Data Bowl. So the tracking data, we've used that. If it's soccer, there's public event data, but we've got 2 soccer projects, which I'll happily talk about in a moment. That comes from our partnership with PFF. So Pro Football Focus FC, their soccer kind of arm, they have collected their own tracking data using video, and they've let us have 1 season, and now we're about to sign on for a 2nd season. I'm not sure we'll be able to make that data public, but we will make code and everything related to the analysis public. So actually, that's a good place for us to start because we just submitted a paper. So this is probably one of our highest level teams because it includes Jonathan Pipping, who's a 2nd-year PhD student. It includes Tian Xu, who's a master's in data science, and he's finishing his 2nd year applying to PhD programs right now. And it also includes Paul Sabin, who's our senior fellow. And they've worked on this soccer at tracking data to do something which they call XG plus. So most people have heard of XG in soccer. XG is the expected goals across a game, and so that way you get credit for goals that aren't goals. So every shot has a certain probability
Is
of
this
going.
XG typically computed at the player level or the team level?
And well, it's computed on a shot level, and you can associate them with players if you like, but this is reported at the team level. So it's usually reported at the game level, and it's usually an underlying metric. So if your team, if you can lose the game in XG, but win the game in goals, and that happens a lot. And so XG
would you, since I'm trying to play as host here, would you relate this somewhat to what in the first half of the show you talked about the Kansas City Chiefs? Like, maybe like there's some underlying metric. In here it's XG plus. Before it was, average length of drive. Maybe that's a bet. There's lots of things, as we all know, that are better indicators necessarily of strength than the actual randomness that happens with outcomes and wins and losses.
Apps is exactly a parallel. And this is a huge leap up in soccer evaluation because there are very, very few goals in soccer. And a game can go 1-0, 0-0 with a shootout. And what are you going to do with that? But XG can accumulate. And in fact, an individual player can have substantial XG. Now, usually in sports, we compare actual goals to XG, and we use that to attribute some special quality to the player, as if they consistently do that. One of the things that we've learned in soccer is that certainly with one exception, maybe a couple others, very, very few people seem to outscore their XG. Their XG is just whatever is you create. By the way, you create your own XG, so you get responsibility for that.
By the way, how can you give our listeners a sense of how that's computed? Is it? I would imagine you'll just tell me if I'm wrong. I would imagine where you're shooting from is part of this, right?
The distance to the goal. Yep.
I would imagine possibly. I don't know. Is the angle?
Yep.
Okay.
Absolutely. Some people were represented by how much of the goal is visible, right? So you take your angle and they can calculate how much of the 360 would be the goal. Right?
The location of the defenders?
Absolutely. They have a metric for that. I mean, it's complicated and these are often proprietary, although we built our own, how you actually take the defenders in to create that. But basically, often what they do is essentially how much of the area is open. Right. So
yeah, you can literally physically say if each player has a certain radius and you have a certain angle and distance, there's a certain amount of openness, and there you go. You could.
So XG metrics can get very complicated because you could take a look at what happened immediately before the shot and integrate that in as well. Like, are you almost like shooting off of the dribble? Or are you shooting off of immediate pass? The Z axis, the height of the ball, could be in it, but usually they are not. Primary drivers are defenders, angle, and distance. And distance is
look. All of our listeners are saying, Eric, when are you going to ask them what's the secret sauce? So what's XG plus? You guys, I mean, it's got to be better than just XG. You wouldn't call it XG plus otherwise.
All right. So just to close the book on XG, Messi is the only player who consistently outgoals his XG, and by a lot. He's just, you can see that just immediately. And in fact, this past Nessus, or New England Sports Conference at Harvard, that he just stuck out in someone's analysis, and that everybody understands. Okay, so what is XG plus? So what our team did is they asked the simple question: XG is only calculated on shots taken. And there are lots of times where a shot can be taken, but for a variety of reasons isn't. And that isn't accounted for in XG.
Very interesting.
So what they did is they calculated any instant, what is the probability of a shot being taken? And then if that shot were taken at that point, that would generate an XG. So you could actually essentially integrate over continuous time this quantity, which is your almost in most instances, the probability of a shot taking is 0, so it doesn't accumulate massively. But you'll end up missing all this opportunity if you only look at XG as opposed to.
Could I, in XG plus, could I penalize a player who should have taken a shot but chooses not to?
Absolutely, that's right. And so players who have all this opportunity that they don't do, they'll get penalized in XG plus, and players who take the shots that they should take, you'll not only see them in XG, but they won't get penalized.
This is now the reason I love this. Besides, it's interesting. Now you could have two different qualities of players. It's almost like false negative, false positive. Some players are false negatives. They should be shooting and they don't. And some players are false positive. They shouldn't be shooting and they do. So you could actually decompose someone's total XG plus, I assume, into almost like false positives and negatives.
You can do a lot with a metric, and it has a lot of the features that you'd like to see in a metric, which is it predicts out of sample well, it correlates with it passes the sniff test, the great players show up. This is produces interesting results, and they're just getting started with it. And I didn't actually collaborate with the research at all.
Yeah.
This is one of the few projects that I had basically nothing to do with it. They just did it and presented, but that large measure is
as you know, Adi, there are a lot of people who listen to us that are academics like you and me, a lot of people in practice. Let me take it from each perspective. First, where does Jonathan, Paul, I forget the other third person's name on the project.
Tianshu.
Yeah. Where do they try to publish this?
All right. So that's interesting. There's a whole bunch of sports analytics journals.
Yeah.
And there are also statistics journals, and sometimes you can publish in sort of operations research journals or econ journals or math journals. So there are the obvious candidate for a lot of research like this would be the Journal of Quantitative Analysis and Analytics in Sports, which is probably the most prestigious sports-oriented statistics journal. There are others. There's the Journal of Sports Statistics, and there's a whole bunch of sports analytics journals. It all depends on how substantive your statistical contribution is, and what you're doing with that. So most of our and so you could also apply to, you can publish in the Annals of Applied Statistics, in JASA. These are very, very elite journals in statistics. If you're making a methodological contribution to statistics as well as just doing a really important insight into sports. One of the things that we always do, in fact, if you want to read about XG Plus without having to wait for the full publication of the manuscript, we have what's called Wharton Research Notes on our Wasabi webpage, which has a popularization of the content. And they explain what they've done without getting into the nitty gritty of the methods or the methods.
I also imagine, I don't know, I assume they may post it like on SSRN, so there may actually.
Yeah, so the archive is what we've been using. That's usually the math to replace for that. Do you have any preference? What do you think? SSRN, archive?
I tend to post stuff on SSRN, but either one. I'm always happy to post stuff through the review process and post it there. And
yeah, so you do SSRN. So we have lots of others.
Tell me about another project.
Yeah, so why don't we talk about one that we do really quickly? One of our undergraduates is working on a rugby paper. So this is really interesting. So rugby is one of the most understudied sports. So his name is Kenny Watts, and he's working with Jonathan Pipping. And so you think rugby is like football, right? There should be a lot of analytics, right? Rugby, football has analytics, rugby has analytics. Well, guess what? There's nothing. So What do if I asked you, what do you think is the first and most important analytics paper in statistics? Goes back around 25 years. In football, what do you think it was?
Wait, what's
What would
the
you say?
most in
What
football,
was
not rugby now?
in football? What question in football was first analyzed with analytics that was really influential?
Um, the
Which
paper,
question in football
yeah, the
is
paper
really
I
needs to
know
be
of
yeah.
is, does the kicker suck or was it the distance?
That's one That's not the one I was thinking of. Um, I did actually
Could
the
you
one
go for it on 4th and 1?
that's the one, 4th down, right? So, in fact, it's called "Do Firms Maximize?" and it's by Romer. And it's written as an economics paper, but it does 2 things. It calculates an expected points model for football, given down and distance and yards to go, how many points are expected on that drive, and he uses that to decide whether or not teams are going for it at the right rate on 4th down, and he comes to the overwhelming conclusion that they don't even remotely. So what Kenny and Jonathan did was they said, "Can we do that for rugby?"
So
It's
explain to
the
me,
basic
I don't
thing.
know even know enough about the rules of rugby.
Neither
Are
did I.
there downs and stuff? Like if you don't get a certain amount or don't score, you have to give the ball to the other team. I always thought as long as you guys keep possessing the ball
But
and
so,
you're going forward on the field, you keep the ball.
so the question that they asked, which I never heard of because I don't know rugby, was that if some sort of penalty happens, and I guess they happen a lot,
Yeah.
the offensive team, the team that has the ball that's subject to this penalty, they get to choose. They can try to kick what amounts to a field goal,
Oh,
which I think is worth 3 points,
it is.
or they can kick it out of bounds, and then they get the ball essentially about 20 yards downfield, wherever they kicked it out of bounds. And it's kind of like going for it because then it score a touchdown, which is worth 6. And then they have an extra point or 2 um, in that formulation.
I
So
just
so
let's be clear. Your team has a penalty. I get an opportunity to either kick it for 3 or kick it downfield. And then, of course, I may end up with 0. But of course, I also have the ball farther down the field. So I'm
and
more
I can get
likely.
to 6 or 7.
Okay.
Exactly.
Well, that's
Exactly the
that.
same thing.
It's very similar. Seems like
Exactly the same thing. And the question became, why had no one done this before? And the answer is data hasn't been available and the sport's far behind. And so our team, Kenny knows rugby. And he asked, let's do it. And they built an expected points model. Um, very similar to the way the Romer built his first one with linear regression, taking every play as having a set of covariates and the outcome, which are highly correlated and have to deal with that, and calculated expense points model. And then he basically calculated what is the optimal decision. And turns out that just as we've seen in almost every sport, they are kicking too many field goals.
that's what I assumed you were going to say.
Yep. There it is. So that was
Can you?
it's a wonderful example because it combines a really important question that people want to know the answer to. We're talking about undergraduates here, so they're trying to flesh out techniques that are pretty standard at this point, and they apply them in a new situation, and they tell us something that we almost expected to happen, but now it actually quantifies it.
Can you give us a sense of like how many points or how much win probability a team is giving up? Like I was like, since I try to be the effect size guy here,
Yeah.
so teams are an optimal, okay, but are they like you've pointed this out even with your work with Ryan Brill? Like people don't go for it on 4th down necessarily always the right time, but sometimes it's not irrational. Depending, like you could come up with a risk aversion story or you come up with an uncertainty story that explains it. Is it that you know? Sure, they're kicking too many field goals, but they're basically not losing much win probability. Or maybe they are. I mean, how big an effect are we talking about?
That's got to be something on their docket. One of the things that when I deal with students is that I teach them pretty aggressively that it's important to finish and not do everything. And
I see. I see. Oh, I thought you meant finished by a different thing. So I'm going to this is not a story.
what I mean is that they need to finish about you know this. It's never done, right?
Right. It's
You've
never
never
done.
done everything.
No, but
And
the story I was going to point out is why, while I publish obviously in both statistics and marketing, in some ways, marketing's just different, not harder or easier, just different because let's say you built this statistical model for something, let's say kicking field goals in rugby or kicking it, then you could never publish that. you'd have to go to the next step. And so what does this mean for firm performance? What does this mean for winning? Like, they will never let you, like, I thought you meant finishing by, and so tell me what this means, as opposed to you have to draw the line somewhere and say, you've built a good predictive model, you've answered an interesting substantive question. You're not yet, you could extend it and say, oh, what does it affect win probability? But at some point, the project just ends. If you're interested in that,
Well,
answer it again.
that's a great question, because actually the getting an effect size, I think, is something that needs to be done before they submit.
I see.
That's too important a question. So they built a model, they have a conclusion, they're not aggressive enough, and now you have to kind of turn it into how many points you're giving up,
Yeah, or something.
and which probably then turns into wins pretty easily. So that piece is I think is important. But these models are going to be incomplete. They're models, right? You're not going to be bringing every factor in, and you could be looking at win probability models instead of expected points models. And there's many ways to do these things. How are you going to be treating how you dealing with the independence? So how you dealing with the standard errors? There's so many deep questions that you could ask, which eventually should get answered, but can't do them all in the first
By
round.
the way, Adi, I would have lost about $1 million. And let me tell you why. If you had told me that you and I were going to talk about
Rugby?
Wasabi-related research, no. The first two you would bring up would be soccer and rugby. I'd be like, I'll give you 1,000,000 to 1 odds. So maybe you could tell us about one that deals with a
Yeah.
sport that I have a little more knowledge. No, I'm not
So
saying there's anything
we
more
have we
difficult, but
actually have
but let
we
me,
have
before
we
you
have a
get to
bunch.
it,
So we
get to it.
we have one in tennis, which
Well,
I don't know.
I love tennis, so get to tennis. But before I do that, I want to point out to our listeners, this what Adi's pointing out is important, which is, I've always said, I joke about it with my friends. There's only one thing we as academics do really well, and that's we recognize the isomorphism between problems. So if you're not a rugby fan and you're not a soccer fan, who cares? What Adi's talking about is applicable to so many other sports or so many other problems. This is why sports is wonderful as a testing ground for statistical methods and learning, because it's, you can change the name from, you know, kicking field goals and scoring touchdowns in one sport to another, or you have two options, A and B, and one is more certain but has lower high end. Yeah, that's what I love about sports, is that you can learn a lot about business and business decision making through sports type models.
You
All right, so
can.
you're going to tell us about tennis.
So tennis actually, this came up. This is a two students did this. They put this together, and and they presented it and at Carnegie Mellon. So let me just tell you who they are. It's Iwin, Rita, and Audrey. Rita, we call her, and so Iwin, Rita, and Audrey. They actually won the student competition award for best paper at the Carnegie Mellon Sports Analytics Conference,
Great.
and it was on tennis. And the feature of tennis is they wanted to rank serves. And the problem with most service ranks is that they don't actually measure the service quality as distinct from the player quality, right? Because you just look how many service points you're winning. Now you can look at aces, of course. That's only one feature of service. The other feature is getting the opponent off balance enough to win the point fairly quickly. But other aspects of your play kind of get involved, and so it's essentially a decomposition of it takes you. If you're winning a lot of service points, it breaks it down into how much of that's due to the quality of your serve and how much is due to the quality of your player. And it gets a
Person serving or the opponent?
Both of them, and adjust for opponent as well. That was a key feature. You got adjust for opponent.
So does it have a ranking of players?
Yeah, and it ranks serves and it's
current players.
Current. I think it has some of that current players. I'll see in there. I can look through their players and see who they rank as excellent. But I'm sure you would enjoy that, right? So that's
I would enjoy knowing, but it is good to know, because it's one of those things where, like, simple metrics. I have a prediction of who the best server is, but it's not going to be someone. If there is a table, is there a table? Should I guess somebody?
I don't actually have it, so you can guess it for next time.
I'm going to guess it's a lesser known player who is 6'10".
Right.
His name's Riley Opelka. I'm going to guess that and you remember from our childhood, Roscoe Tanner.
Oh, it's Roscoe Tanner. Yeah.
No, I'm just saying. Roscoe
50 miles an hour, Roscoe
Roscoe
Tanner, right?
Tanner could serve. Roscoe Tanner could really serve. That was the
I think
only
that's
great
all he
part.
had, right?
It
That's all.
is, and
That's it.
but either way, that's a fascinating project.
So yeah, and those had great success, and it's funny because I mean it's actually really nice to see these students all work with me, or they were all Moneyball Academy TAs in part of our lab this summer, and that's where they did their work. I can finish up with a few others.
Yeah, please
We do
do.
we have two actually pretty good ones in
Maybe two
football.
more. Two more would be great.
Yeah, well, so one of them in football. We have a soccer, we have football, we have a baseball one that's just getting started that we just submitted to Sabre,
What's the
which is
question in the baseball one?
and the baseball question actually, so it has to do with my historical admiration of the RBI, and so the RBI statistic, everyone likes to make fun of because it's contextual, right? It's so dependent on the settings, the opportunities you get, so that just essentially is just asking you to adjust for context. So the question we asked was, what are your RBIs above expected?
That's very reasonable.
I'd love to know, like Lou Gehrig's 180 or Hack
Well,
Wilson.
Lou Gehrig, the thing, this is what you're pointing out. The greatest season I've ever thought about was when Lou Gehrig hit 100. This is 1927, the year Ruth hit 60. So we know he came up at least 60 times with
Right.
nobody on
Yeah.
base. He had 175 RBIs. I think Ruth had 160 something. So how many guys were goddamn left on base by the time Gehrig got up there? And he still hit 175, I think is the number.
So to me, that's an obvious. You always ask for. It's not one of the most obvious unanswered questions in baseball. If you
Yes.
report RBIs, you should also be reporting RBIs above expected immediately. And then you could also, and this came from our conversations with some of the analysts at the Phillies. They want to know what your RBIs above expected is after controlling for the quality of player that you are. So we know that, right? So a lot of that RBIs above expected could be due to the fact that you are a great player. So that. So they want to decompose the RBI above expected into two pieces. One, which is what you'd expect to get given the quality that you are, and then the additional part, which would essentially be the luck or the you can call it luck or skill to drive in those extra RBIs or pressure, performance.
Let me ask a
And they
question.
actually
To
were
that
interested
above
in.
expected part, I can imagine a bunch of, I can imagine a statistical model, but I can also imagine just binning players into quality buckets or terciles, let's say, and then say, of the players in this tercile based on some metric or something or some skill estimate, let's look at how many RBIs above expected they have for their decile. That would be one way to do it. Would you favor that over some sort of, let's call it parametric type or some sort of model?
Well, I generally my general tendency is to use a parametric model and essentially predict your RBIs given your context and your say WOBA. That's a
Okay.
simple way to do that. I like your bucket. In fact, Eric, I'm going to ask you. You want to be the faculty advisor to our little team? They'd certainly love to have you.
I'd love it. Let's do it.
So we have two undergraduates working on it right now. Talia and Liev are sophomore and freshman. In fact, Liev took Moneyball Academy, and he's now here as a freshman and is already jumping in to do research. I finish off with the football.
Please
These
do.
guys in Harvard and did a great job. They did something that everyone is interested in. We look at win pass. That block brush win rate, right? That's a standard statistic that gets calculated. But guess what? It's not doing. It's not adjusting for quality, the quality of your opponent. And that is something they want to do. And this team has tried to adjust for the quality of the opponent and the context and the actual what's at stake, right? So failing to block in a situation that doesn't really matter is much less important or damaging than failing to block or succeeding to block, and it leads to a pressure or a sack. So essentially, want to do is a much more sophisticated evaluation of both the blockers and the rushers, and they came
Ah,
out with great results. And it's much better than just success rate uh, block pass success or rush win rates.
well, the reason I love all these stories is, first of all, it's great that you're giving back to our students and giving them an opportunity to do research. That's obviously number one. That's great. It's great. And a lot of these people, as you said, may go on for research jobs in industry or PhDs, etc.
More of them are applying for statistics PhD departments.
Yeah, well, that's, I mean,
Great.
that's incredible. The second thing is it shows people that, um, you know, you don't need a PhD to do interesting research too. And so that part is interesting. That part is really interesting as well. Well, this has been 1 hour here of Wharton Moneyball on the Wharton Podcast Network. On behalf of myself, Eric Bradlow, my colleague, co-author, and friend Adi Wyner, uh, in absentia, Cade Massey and Shane Jensen, who'll be back next week. Thanks to our associate producer and sound engineer, Dion Simpkins. Thanks to our producer and, if you like, our big bosses, Marissa Renna and Dee Patel. Thank you for joining us here on Wharton Moneyball. Between now and next week, enjoy your sports, enjoy your statistics. We'll see you back here on the Wharton Podcast Network.